and your correlation is based on the 30-inch plate load test, right? And this is the value, and the more accurate K if the plate test one was run with bigger plate. However, of course, it may be too expensive or impractical for you. So it all depends. Okay, what is your capability? So the modulus is used to estimate the support for the PCC slab by the layer below, and it is calculated which reflects the base subgrade contribution as well as the loss of support that occurs over time due to erosion. Okay. So if you are designing it with subbase, okay, if you are designing with subbase, then you need to determine the composite modulus of the subgrade reaction. And so this is if you have an extra subbase, and if you need to check the CBR value of your subbase as well. So if you have a CBR value of 10, then you need to input your K as 200 pound per inch cube. Okay. So when we look at the subgrade strength, it's given in terms of Westergaard modulus reaction, and it is estimated that the composite modulus is defined in terms of its elastic modulus. So this is the chart which is used to estimate the composite modulus of subgrade reaction for the type of subbase material based on its elastic modulus and its resilient modulus and the thickness of the subbase. Okay, so this is an example. Okay, so you look at this chart. This chart is based on H-slow. That is why you look at the chart. It is basically using imperial units. So when it comes into, like I mentioned earlier on, at the moment, we don't have our own Malaysian. I think we have our own, but it is not fully utilized because, as you know, our road system here, we design for flexible. There is hardly any road that we design for rigid pavement. So it's not widely used. So when it is not widely used, the standard may not be available. So what if you are asked to design, you can use the AASHTO standard. Okay, AASHTO. But if I look at from my reading, AASHTO standard is one alternative. The other alternative that you can use is the Indian standard. Indian standard is also quite comprehensive when it comes into designing rigid pavement, but nevertheless, it depends on your project. Let's say if your company or your consultant company receive an offer to do rigid pavement, then you have to ask them what type of standard they use. Most of the time, if you follow JKR, they will ask you to use AASHTO lah. But nevertheless, there's another alternative, which is the Indian standard. Indian standard is also very, very much comprehensive when it comes into the design of the rigid pavement. Okay. So this is where you look at, you do the assumption of your subbed thickness, and then you check what is your road bed soil resilient, and your subbase elastic modulus, as well as your composite modulus or subgrade reaction. Okay. Let me go into this. This is the one I show you the example. Okay. I think the example is much better for you to look at. Okay, see. Let's go into this. The example, okay, this is additional. If you want, I will add on this to the slides to the notes for you. Okay, so the design consideration is based on AASHTO design method, and this example is taken from page 1099. If you bought the book Nicholas J. Garber or Lester A. Goel, okay, this is under chapter 19, and you go into the example. Okay, let me go into example. So how do you compute effective modulus of subgrade reaction for rigid pavement using AASHTO method? So the example, the question is that a 6-inch layer of cement treated granular material is to be used as subbase for a rigid pavement. So the monthly values for the road bed soil resilient modulus and the sub-base elastic modulus are given in column 2 and 3 of table 20.6 on the following page. If the rock depth is located 5 feet below the subgrade surface and the projected slab thickness is 9 inch, estimate the effective modulus of subgrade variation using the ASTRO method. Note that this is the example given in the 1993 ASTRO guide. Also, note that the value for the modulus of the roadbed and subbase material should be determined. Okay, should be determined as discussed. Okay, so this is the data. Okay, so this is the data for and the solution for this. First of all, is before we use the chart, we need to have this data. Okay, what are the data? You need to know what is the roadbed modulus in January, in February, in March, April, May, June, July, August, September, October, November, and December, okay, as well as the subgrade modulus, ESB, for the 12-month period. Okay, so you need to have the first data that you need to know is number 2 and number 3. You need to know that. And of course, you need to based on the question, the type of sub-base used is granular, and the assumption is that we are building the thickness of the PCC is about 6 inch, okay? The slab thickness is about 6 inch, and the loss of support is about 1.0, and the depth to rigid foundation is about 5 feet, and the projected slab thickness is about 9 inch, okay? So this is the values that you need. If you look at this roadbed modulus, okay, why they are different values? There are changes in the values. For example, in January, February is 20,000 pound per square inch. March, April, May, June, July, August, September, October is the same value. November is a slightly different value and another one. Anyone can answer that. Apa sebab dia? Roadbed modulus is different. And from where do you get this roadbed modulus? Anyone? Boleh? Can type in the chat. Tak ada orang kan? Any reason why there is a difference between this? Tak ada orang. Anyone? Not the thickness. Okay, first of all, first question is, where do you get the roadbed modulus and also the subbase modulus? From where do you get the value? Not necessary from material complete. The pound per inch square. Daripada mana you dapat? These two values, roadbed modulus and subbase modulus, usually you take it from the CBR. You need to do CBR test in order for you to get the modulus, subbase modulus, and also roadbed modulus. Because you need, the first thing first is that you must have the CBR value, okay, for your road base modulus, and then after that, after you take the CBR value, then you convert it into a modulus, okay, roadbed modulus or subbase modulus. So you have to do the CBR testing first. And then what makes it different, okay, what makes it different is because if you are in the States, US, in the US, you have 4 seasons. You have 4 seasons. As you can see here, towards the January, February, December, January, February is somewhere in the winter. It's a winter time. Then when you look at the winter, then you have the spring. Okay, you have spring, and then somewhere in June, July, August. Okay, June, July, August. That's where the summer. Then after summer, it will be autumn. So the coldest month will be somewhere in October. Somewhere in November. So that's why you look at the resilient modulus. When you do it every year, every month, you collect, you do the sample, you do the CBR sample each month. Technically, if you have a 4 season, you will have a different modulus, because of the temperature effect and so on and so forth. But if you are doing it in Malaysia, for example, what will be the value like? Would it have any variation or similar? Okay, right? So if you do it, the test in Malaysia, okay, basically what you get for roadbed modulus and subbase modulus is the value should be similar, right? More or less similar. Of course, maybe there's a little bit of variation depending on the location. And sometimes it depends on the location of the material that you obtain as well. But in terms of the variation, it's not much. Maybe 5% difference value in terms of the difference value, maybe about 5%. Right? So this is where you need to have all this, okay, in order for you to use the figure. So next, once you have the solution is that, okay, having determined the different moduli as given in column 2 and 3 from the table, the next step is to estimate the composite subgrade modulus for each of the seasonal periods considered. At this stage, the effect of the existence of bedrock within 10 feet from the subgrade surface is not considered. And it is assumed that the subgrade is of infinite depth. Okay? So infinite depth means that you assume that it is straight away to the core lah. So the composite subgrade K is then determined for each seasonal period. So you have to notice here, there is the composite subgrade is determined for each seasonal period. So the procedure are as follow. First, you estimate the K effective. Okay. For example, in September, the roadbed modulus is 7,000 and subcase modulus is 20,000. So you look at the chart, at this chart, okay, and you draw a vertical line. Okay, you draw a vertical line from the 6 inch. Your estimated subbase thickness is 6 inch. So you take from the 6 inch and you move up towards your subbase elastic modulus, ESB. Okay, so which your ESB is about 20,000. So your 20,000 is somewhere near the point A, is between the 15,000 to 30,000, okay, pound per square inch. So the example here is already given. MR, okay, MR for your road-based soil resilient modulus is about 7,000. So you draw it down towards the 7,000. Is it 7,000? Or terbalik? Oh, sorry, terbalik. ESB is up, ESB is up, MR is down. So why the MB is it looks like it's the other way around. It should be somewhere 7,000. Okay, look at the point here, 7,000, and you draw across a line, and then so you get your solution is about 400 pound per inch. Okay, this is for assuming a semi-infinite subgrade depth. Okay, so you adjust the presence of the rock bed within 10 feet of the subgrade surface. This involved the use of the chart in 2011. This chart takes into account the depth below the subgrade surface at which the rock bed is located and the resilient modulus of the subgrade soil and the composite modulus subgrade reaction determined earlier. So the adjustment is made as follow. So you enter from the figure 2011, okay, at this, okay, you adjust it from the resilient modulus of 7,000 pound per square inch, and then you draw a line. Okay, you draw a vertical line to intersect the graph corresponding to the depth of the roadbed below the subgrade surface. In this case, 5 feet. Okay, as you can see here, from your 4,000, okay, you draw up, MR 4,000, then you draw up, and then you get about 4,000 pound, correct, 4,000. So your intersection point is A, right? So when your intersection is A, then the next point will be from A, draw a horizontal line to intersect the appropriate K line. In this case, intersection point is B. Okay. From B, you draw a vertical downward, so you get about 500 pound per square inch. So what happens is that you draw a vertical line, okay, your subgrade depth to rigid foundation is about 5, okay, 5. So you draw a line at 5, draw across with B, and touch where your semi-infinite subgrade is about 400 pound per square inch. And then you draw it down, then you get your K, right? Your modulus of subgrade reaction K of 300 pound. Okay. So the third one is you use the effective modulus of subgrade reaction by determining the average damage. The steps involved are those for, but in this case, you use the 2012 figure. So what happened is that you use 2012, okay, which is this one, right? So what happened is that you take the value in step 2, which is about 500 pound, and the project vertical line representing the projected slab at 9 inch. Okay, so you take this 500, so you go up about 9 inch, then you draw a line across. Okay, so from there you get your mean of U is about, UR is about the damage, average damage is about 0.6. Okay, so you get about 0.6. So then you adjust the effective modulus, okay, to have the potential loss or sub-base support due to erosion. So this is 2010 below. The LS factor in 20.5 is used. So your LS is 1 lah. So you use 1, then you get your subgrade reaction is about 500. You draw a line up and touching the LS1, and then you draw the line across. So you get the subgrade reaction correction. The correction due to erosion is 170 pound per inch cube. So that is the steps lah to use for what's that? If you use this graph. Ada soalan? Any question so far? Okay, I'll give you the slide, the new slide later on, and then what happened is that you guys try to look at it again and then compare to what has been mentioned in the what is that, in in the in the video recording. Okay. Step 3. Okay. Kalau untuk step 3, okay, what happened is after you have obtained the value, okay, you have obtained this value, for example, from the figure 2011. So what happened is that you use the figure 2012. So this is the figure for 2012. Okay. So you use this figure, okay, to identify your relative damage. How do you identify relative damage? You take the value from 2012, okay, sorry, in step 2, which is about 500 pound per inch square, and you use this table, you find the 500 pound, okay, 500 pound composite K value, 500 pound at the bottom on the x-axis. Okay, what happened is